good to go. Outcome 1. Working with radians and degrees. All right. I will also say that I do print out my notes. If you're a student, that it's better for you to write down notes because that's going to keep you concentrating, then by all means do that. But I know some students, if they have to write down the notes, they're concentrating so hard on writing down all the different stuff that they can't really listen to me and actually gain any more understanding about the concept. So if you're one of those students, then just listen and I'll type out or print out the notes after the class, okay? Or get a friend who you know takes good notes and ask them for theirs. So you have to know about your learning in that regard, what's best for you. So I expect you to make the best choice there for that. Yeah, because I don't put everything on here, and so you might find that little notes on the side are helpful for you. So anyway, we're talking about radians versus degrees. On your calculator, you may have noticed sometime when you've been doing a trigonometry problem that you pressed the sine of an angle and got some kind of weird value, and all of your answers were incorrect, and somebody may have told you that you had your calculator on the wrong mode, you need to change it to degrees. I don't know if that's ever happened to you. Usually before an exam, I ask students to check it because the last thing I want to do is check 20 different answers that are all, the work is all correct, but the numbers are all off, and I have to make sure that they're all done correctly because they have the calculator on the wrong mode. So radians, degrees, there are different ways to measure the same thing. Both measure angles. So we know that when we talk about our unit circle, for example, we know that the different values are 0, 90, 180, 270, and 360 degrees. Right? That's what you talked about last year when you went around the unit circle, right? So why 360 degrees? It's actually a fairly arbitrary number. Why did someone decide to divide a circle into 360 parts and call them all degrees? If you think about it, there's not really anything relevant anywhere else in the world that would say you should divide something into 360 parts. It's kind of arbitrary. They could have easily divided into 100 parts, and there is actually one that does that. That's called gradients. So there's different ways that you could do this. So they could have also divided it into, whatever, 200 parts and called them SAMs. There's 200 SAMs in a circle. And we could all be measuring things according to how many SAMs they are. Right? It's really quite arbitrary how they came up with this 360 parts. So we're going to look at a different way that you can measure those angles. Now, converting is actually quite simple. The process isn't too hard. Radians. 180 degrees is the same as pi radians. Pi. Well, that makes it kind of weird. Now they have to throw in a number that isn't even really a number, right? It's an irrational number, pi. So 180 degrees is pi. Why did they come up with pi radians equaling 180 degrees? Well, there's actually a connection to it. And I'll show you the connection. If you think about the unit circle, okay, so if you think about a circle that has a radius of exactly 1, all right? Its radius is 1. That's the unit circle. A radius of 1 around the center of 0, 0. If I were to ask you what the length of this arc length is, well, it turns out that, let's say this is pi, right? So this would be half of pi, 90 degrees. So that would be pi over 2. let's say this angle was 45 degrees. That would actually be pi over 4, wouldn't it? Because it would be half of pi. Get the connection? Pi would be 180. I'll put the numbers here. Pi would be 180. Pi over 2 would be 90. And if I took 45 degrees, it would be pi over 4. Well, it turns out that pi over 4 is actually the length of this arc length. If you actually measured the length of that arc, it would be equal to pi over 4 centimeters if this radius was 1 centimeter, or pi over 4 units if this radius was 1 unit. It makes sense if you think about the circumference of a circle. The circumference of a circle is 2 pi r. Circumference, right? Remember that? All the way around. So, if you think about it, the radius is 1 though. If the radius equals 1, the circumference would be 2 pi. In other words, all the way around the circle, that distance would be 2 pi. Which makes this 1 pi, which makes that half a pi from here to here. So that's the reason radians are significant, because they actually represent something that's real. They represent the part of the circle that is cut out. Okay, so that's why we use them. And they're the default, actually. So if I tell you an angle has a measurement of 3, I'm actually saying it's 3 radians. I have to put a degree symbol after it to indicate degrees. Okay? So, now that's a lot of talk, and I'm trying to set it up and explain why this is working. Here's the part you really need to know. How to convert. Well, it turns out all you really need to know is this. Pi radians equals 180 degrees. So you just have to remember that fact, and then you'll be able to figure out how to convert. Now, I don't know if depends how you've learned conversion, but this is the way that I like to learn conversion. So if I was going to convert 70 degrees into radians, okay, what I like to do is, it's called unit analysis. And you'll find this is very helpful in physics as well, if you're taking physics. I am going to go to radians, right? I'm going from degrees to radians. So I want to get rid of the degrees. So now I have to write a truth statement that connects degrees to radians. Well, the truth statement is this. 180 degrees equals pi radians. So I write it this way now. 180 degrees, pi radians. Now, I call it unit analysis because what happens now is I have a degrees over a degrees. You see that? So those units cancel out. So therefore, my answer is now going to be in this unit, which is radians. You follow that reasoning? Okay? So now I just have to multiply this fraction. Well, what do you do when you multiply fractions times a whole number? We write it as over 1. We multiply straight across, and we end up with 70 pi over 180. And I don't have to write the units, but it's now in radians. Okay. I'm multiplying a cross, actually. I'm multiplying this way. I'm not really cross-multiplying, because then you would, like, I'm not, maybe you're saying the same thing but meaning something else. Okay? So that's the way you should multiply, like railroad tracks, straight across, right? Now this is the answer. It's converted. Okay, it's converted into radians. You might want to feel better if you actually multiply it out and do 70 times 3.1415, etc., and divide by 180. But you're not required to. This is the answer. You could reduce this fraction easily by canceling out the zeros, and writing this as 7/18 of a pi. But either way, it's converted. You'll get full marks for either form, 70/180 or 7/18 of a pi. Notice here I have the pi on top, but I could also write the pi on the side. Right? Either way would be acceptable. They both mean the same thing. You okay with that? Okay, I'll show another example. So suppose you have something like this. 72 degrees. I'll make it 144 degrees. 144 degrees. So if I want to convert it, again, I need my truth statement. 180 degrees equals pi radians. And I want the degrees to cancel out, so I put that on the bottom and I put the pi on the top. I multiply across, 144 pi over 180. I don't have to write radians because that's the default unit. So that is the answer. It's fine. I can reduce it if I feel like it. And I guess the only time where it would really matter is if your answer is in a multiple choice and you have to recognize which one is your correct answer, and they probably would put it in reduced form. So in that case, you could reduce this. And you could see that, I don't know, 9 goes into both of these things. It ends up being 16 over 20 pi, which ends up being 4/5 of a pi. But again, this answer is totally correct if all I'm asking you to do is convert. The only reason this answer would matter is if it's a multiple choice question. And I'm not a big fan of that for my tests. Okay, is that fine? You get this? Okay, let's look at converting the other way. What about if you go from radians to degrees? So suppose I give you something like 7/9 pi equals how many degrees? So you have to convert that. Okay. Well, again, I would say same thing. Okay, I'd probably put the pi on top. That would make it a little easier. Again, I'm going to say I want my truth statement. My truth statement is that pi equals 180 degrees. But now I want to cancel out the radians, right? And I want to go towards degrees, don't I? So that means now the 180 is going to go on top and the pi is going to go on the bottom. Does that make sense to you? Okay? And you can see this works out quite nicely because the pi's are going to cancel out. And now I'm going to do 7 times 180 divided by 9. You could use your calculator to do that. There's also a bit of a shortcut. You could do the division first. 180 divided by 9 is 20, right? It's like 18 divided by 9 with an extra 0. So this division would be 20, and then times 7 gives me 140 degrees. So you could do that without a calculator if you recognize that trick. If not, use your calculator. That's okay for now. Okay, everybody okay with that? All right, now this value does not need to have pi in it for it to be in radians. I could also just give it to you like this, 2.93 radians. If you think about that, since pi is 3.14, this is indicating an angle that's just a little bit less than pi. Right? If I had to think about where that angle would be, it would be somewhere around here, because remember pi was here. So this would be 3.14. This angle is a little bit less than that, right? Does that make sense? Okay, so there's no pi in this answer. But I still convert it the same way. I'm going from radians to degrees. So the method is the same. 2.93 times my truth statement, and I want to go to degrees, so degrees has to be in top, pi has to be in the bottom. But now I will have to use my calculator because I can't do 2.93 times 180 in my head. Okay, and I will actually want to divide by pi then, because since the pi's aren't canceling out, I really don't want pi in my answer. So what do I get? I should get an answer that I know should be a little bit less than 180. So somebody done it? 2.93 times 180, and then you'd have to divide by pi. Graham, you got it? 167.87 degrees. And I should put a degree symbol on there because degrees need to be recognized and written. Or, oh, okay, so that's probably dependent on whether you use 3.14 or whether you actually use pi. Yes, you should actually use the pi button, because as soon as you use the 3.14, you're rounding off, and you can see your answer is just a little bit off. That's an important point in grade 12. All your answers are supposed to be correct to 3 decimal places. So you should never round off in the middle while you're using a number. You should only round off at the end. Okay, well, that's good. Like I say, it's not a conceptual error. It's just an accuracy thing, right? So that's that. Is everybody okay with that? We can do that? Conversion? Okay. Here's your last outcome from today. So we know how to convert from radians to degrees. We know how to convert from degrees to radians. The last outcome is using the formula, and it's given to you in your formula sheet, S equals theta R. So, of course, you have no idea what this means, so I'll tell you what it means. This is this connection that I've alluded to before about a circle, and if I have an angle in the center, right, the connection between this angle theta in radians and the arc length that it cuts out. Remember? What's that? Oh, good. Theta is a Greek letter that we use to represent an angle. Usually in math, when we ask you to solve for a number, then we call it x or n, something like that. But when we're asking you to solve for an angle, then we give it Greek letters like theta or alpha. So it represents the unknown angle in this case. All right. So anyway, I told you there's a connection between these two, that this arc length here in green would equal this angle in green if I gave you the angle in radians, right? Well, it turns out that it kind of makes sense. If this radius was 5 here, then that means this arc length would just be 5 times theta. So there's a direct connection between the arc length and the angle here with regards to the radius. This is what it's the same. So here. Oh, that's not what I wanted. There's my arrow. Oh, there it is. So we have these 3 parts. This obviously represents the angle. But the thing is that angle must be in radians for this thing to work. It doesn't work if it's in degrees, right? If this angle is 60 degrees, this arc length isn't 300 centimeters. That doesn't make sense. 60 times 5, right? It only works when you measure this angle in radians, okay? The R obviously stands for the radius, and then S stands for arc length. So by arc length, we mean the length of this arc that it's cutting around here in the corner here, right? So if I straightened it out, how long would that thing actually be? Does that make sense? So here's a typical question. I'll give you 2 examples. A circle has a radius of 20 centimeters. Central angle is 60 degrees. Find the arc length. So they're telling you that there's a circle here, and we cut out a central angle of about 60 degrees. And we know this radius is 20 centimeters. And what we're trying to find is the length of this arc here. cut out by that angle, right? That's what we're trying to find. Well, as soon as you see the word arc length in the formula, in the question, especially in this assignment, since we're talking about arc length, you should know that you're going to be using this formula. S equals theta r. Okay? But you can't just write in 60 and 20, can you? What do you need to do first? What's that? Yeah, you need to convert it. Good. Theta must be theta. Oh, I should use this. Must be in radians. So if it's in radians, like if I gave you this as pi over 3, no problem. You can just multiply 20 times pi over 3 and that would be your answer. But I didn't. I gave it to you in degrees, so you need to convert it. So we're going to take 60 degrees. We're going to multiply it by our truth statement. What's going to go on the bottom? Degrees, good. 180 degrees, and the pi is going to go on top. And you can see that I'm going to end up with 6 pi over 18, because the zeros will cancel out as well, which equals 1/3 pi. That's fine. You don't have to convert it if you don't want to, or reduce it, because you're going to use it in the formula now, right? So now we could use the formula. S equals 1/3 pi times 20. Right? Because that's the radius. Now the formula works, because we converted it into radians. So now you can punch it into your calculator and see what the actual answer is. It should be just under 20, I think. No, just over 20. What's that? 20.94. And since the original question was in centimeters, this unit has to be in centimeters as well. So you have to write down your units. Does that make sense? Everybody okay with that? So really, this is a quite simple formula. Only 3 variables in it. The question will always give you 2 of them and ask you to solve for the 3rd one. But the thing that you have to remember is the angle is always in radians, right? Do you need another example of that or no? Okay, there are 9 questions, I think, for you to do. You should skip past the prerequisite skills, and you should go straight to, I guess it's like the 4th page or something, the back of the 4th page. Assignment number 1, Unit 1, and there are 10 questions there for you to do. Oh, I see, yes. I should show you one other thing, I guess. When I ask you to draw in standard position for number 3, you've done this before, so if I ask you to draw 150 degrees in standard position, it would look something like this. This is how you draw 150 degrees. Right? You know that it's 90 till here? Okay, so it would be somewhere around here. Does that make sense? If I asked you to draw, let's see, 5 pi over 4 in standard position, you should know that it's 1 pi to here, and each quarter is half a pi. Does that sound right? Each quarter of these is half a pi. Half a pi, 1 pi, 1.5, 2 pi, right? So this 5 over 4 represents 1.25 pi, right? 5 over 4 pi equals 1.25 pi. So in standard position, that would be going here to 1 pi and then down there, about halfway down there. I won't ask you to be that specific. I'm not going to measure them to see sure that they're halfway, but you should know that it's in the third quadrant here. Okay? And I guess I could also ask you to just draw it like this. Where would 6 radians be? So now I don't give you a pi, I just give you the number 6. So you need to know that this number is pi, so that's 3.14 radians, right? That makes sense. And so that means 6 radians would be almost all the way around, right? Because this would be 6.28, right? It would be twice of 3.14. Does that make sense to you? Okay? So in number 3, they ask you to draw a few angles. So you just kind of have to know about where they are. At least get the quadrant correct. Okay, I think you're ready to go. Yeah, try them.